Hi, and welcome to 2.3 on special cases in solving equations. So in the first one here, we're going to look through this solved equation and see if we can figure out where the mistake is. So the first thing they did was they took this 5 that it was being divided by and multiplied it on both sides, which is okay to do. And then the 5's go away, and they have that, and then 4 times 5 is 20, so that works. And then they do -2 times x, which is -2x, and -2 times -3, which should be +6. So here's our mistake right here. And so then we circled it, and we're going to show the actual work. So we don't need to do the stuff that they did right again. Let's just start here. So we're going to start with -2x plus 6 equals 20, and then subtract 6 from both sides. -2x equals 14 divided by -2, x equals -7. Okay, now we are justifying based on properties of either equality or real numbers. And this is review of what we've already done. So go ahead and pause this and try it yourself. If you need to look back at the list of properties, go ahead and do so, and then come on back when you're finished. Okay, so here are the answers for this one. This one is distributive because they distributed all of those numbers. Commutative because they switched some of the numbers around. So the -2x and the +6, they switched those. Distributive, where so this is actually like the opposite of the distributive property. And then identity because, let's see, because 3 minus 2 is 1, and then x times 1 is x. So they kind of did 2 steps at once there. The next one, addition and subtraction property of inequality or of equality. So they're adding and subtracting numbers to both sides. Commutative, they switch numbers around again. Zero and substitution and distribution, they're doing more than one thing at once, and then dividing both sides by the same thing. Okay, so now we're going to try a special case here. So sometimes, even when we have everything justified, like basically we're doing something right, you can get a funky answer at the end. So like this one, they distributed the numbers, and then after that they subtracted from both sides. So that's going to be the subtraction property of equality. And then on this one, they factored that x out, so that is the distributive property. And then they also did 5 minus 3 is 2, and then 2 times x, so that's also substitution property. They're telling us that that's the additive property. They're adding things to both sides. And then here, when we do 2x minus 2x, that's like 2x plus -2x. It's the additive inverse. And yep, that's it. Okay, so that's the additive inverse, and then we end up with -11 equals 0. So everything is justified. We did everything right, but it looks funky at the end. We don't have an x equals whatever. So is this a true statement? No, -11 does not equal 0. And is there any value of x that could make it a true statement? No, because we don't even have any x that we can substitute anything for. So what this tells us about the solution, and you guys have seen this before, it's no solution. And you can also use the abbreviation that looks like that, which means no solution, or the solution is the null set, which means it has nothing in it. Okay, let's look at another one here. So on this one, we're going to show that x equals -5 and x equals 2 are both solutions to the equation. So I'm going to do the x equals -5 first, and I'm just going to substitute the -5 in for x. So I've got 7 times -5 plus 2, -5 plus 5 equals 9 times -5 plus 10. So now I'm going to do my parentheses stuff first. And so this is 7 times negative 5 is negative 35, plus 2 times, that's 0, equals 9 times negative 5 is negative 45, plus 10. This one is negative 35. That's 2 times 0 is 0, plus negative 35, and then negative 45 plus 10 is negative 35. And since I have the same thing on both sides, yep, negative 5 is the solution, it works. Now I'm going to do the same thing with negative 2. So 7 times negative 2 plus 2, negative 2 plus 5 equals 9 times negative 2 plus 10. So I've just put in negative 2 for all of my x's in the equation. That's up here. 7 times negative 2 is negative 14, plus 2 times negative 2 plus 5 is 3, equals 9 times negative 2 is negative 18 plus 10, negative 14 plus 6, negative 18 plus 10 is negative 8, and negative 14 plus 6 is negative 8. So negative 8 does indeed equal negative 8. That means that both of those solution works. So now it asks us to solve by manipulating each side. So like the normal way we solve equations. So I'm going to start with 7x plus, and I'm going to go ahead and distribute. 2x plus 10 equals 9x plus 10. And then I'm going to combine my like terms. So 9x plus 10 equals 9x plus 10. So at this point, hopefully you can see that both sides are exactly the same, and no matter what I put in for x, it is still going to be equal to each other. If you wanted to subtract 9x from both sides and go down to 10 equals 10, that's fine too. It's always going to be equal to each other. So the answer to this one is infinitely many solutions. Okay, now I usually have people ask at this time, can you substitute that in for infinitely many solutions? Like, will I know that's what you mean? Yes, that's fine for me, but in general, that is not a solution for, or it's not a symbol for infinitely many solutions. It just means infinity. So yes, you can do it for me. I know what it means, but I wouldn't do it on standardized tests. Okay, so now they want us to test our conclusion by picking a random integer, anything we want. I'm going to pick 100 because why not? So I've got 7 times 100 plus 2 times 100 plus 5 equals 9 times 100 plus 10. So I've got 700 plus 2 times 105 equals 900 plus 10. And then that gives me 700 plus 210 equals 910. So 910 equals 910, and it does work. So any number that we put in there is going to give us equal numbers on both sides. They will all be a solution. Okay, so you can, and sometimes this is helpful to do when we sort of estimate or look for, make sure our answer is reasonable. We're going to, without solving these, decide whether there will be one solution, so the way it normally is, no solution, or infinitely many solutions, and then say why. So this one is exactly the same on both sides. When we see exactly the same on both sides, so the same, that means that we have infinitely many solutions, because anything that we put in for x is going to still make it the same on both sides. Okay, this one, we have the 2x on both sides, but we have the -4 and the -7, which are different. So if I subtracted 2x from both sides, I would have -4 equals -7, which is not true and is never going to be true. So that is no solution. And then this one, if we were to add 5 to both sides, we would get rid of these, but I could have 3x equals 6x, and if I put a 0 in there, that would be the case. So this one is one solution. Okay, so I want you to try these 4 at the bottom, pause it while you give them a try, and then come back and take a look at the answers. Okay, so here we are. For this one right here, our answer is x equals 0, so one solution. This one, no solution, because 30 will never equal 0. On this one, infinitely many solutions, and this one down here, x equals 0. So please write down any questions for me that you have so we can answer them in class. See you later.